We have a feasible process now, but this process is not very sustainable because we are feeding here around 110 cubic meters of fresh water, and then we throw this water away. Of course, we need a regenerative process. So we see here in this water, we have around almost 1,000 kilogram of carbon dioxide, and we have to remove this. How can this be done? Well, with a stripper column. So we have another column where we use air in order to remove the carbon dioxide from the water. How can we remove it? Well, we can reduce the pressure and or increase the temperature. And we have an inert gas flow. In our case, this will be air in order to strip the carbon dioxide out of the water. So let's try this. We add another column. So again, we use the SCDS column. With right click, can again get such kind of column without condenser and reboiler. And we feed our loaded water stream to the top of this column. Arrange this a bit. Okay, I reroute the stream. Okay, to the top of the column. Here we have our clean biogas. And now we want to use an airstream in order to remove the carbon dioxide from the water, which is fed to the bottom of the stripper column. And we have a product and the regenerated water stream. Streams 6 and 7. With this zoom to fit, we can have a look at our complete flow sheet. Now we have to modify our component list because currently we have no airstream in our component list, but we want to use air for the removal of carbon dioxide. So we go to select components and we have a mixed component, which is called air, which contains nitrogen and oxygen. We can use this for stripping. I order my components by having it from the light boiling component to the heavy boiling component. So I will put the air here on top of my component list. Okay. And now we can specify here our airstream. So this should be dry air. So we have here 100% of air. Question is, how much air do we need in order to strip our 110 cubic meters of water? Well, let's give it a stream of 1,000 cubic meters per hour. You already see we will have another optimization variable for optimizing our process later. To remind you, currently we are working with the temperature of the wash water, with the pressure inside the scrubber column, with the flow rate of the water, and with the number of stages that we have in the scrubber column. So our variable number 5 that we have is the amount of stripping air that we use. Let's assume this comes at ambient temperature and pressure. Okay, our stream is ready. We can give it a name. So this is our stripping air. And we have to specify our column. So again, we can use 10 stages here, like in the scrubber column. And the pressure at the top of the column, we want to reduce the pressure. So we can use here ambient pressure, top pressure of 1 bar. Okay, zoom to fit. And we run our flow sheet. You can see here, let's look into the streams. We remove almost all carbon dioxide. So let's look at the different streams. We have the loaded water and the stripped air. And from the mass balance, we can see 981 kilogram of carbon dioxide are coming into the process and 981 kilogram are removed. So we almost completely regenerate our water. You can have a look at this. This is the regenerated water. And we notice there's very little carbon dioxide left. If we want to see this in mole fractions, we see we are here less than 1 ppm of carbon dioxide. So probably I used too much air, but for a process in the beginning, this is good. And this means now we can recycle the water back to the column, to the stripper column, and to reuse it. Give it some names. So this here is my off gas, where I remove the carbon dioxide and the stripping air.